Morning, students. This is another session of free tuition on trigonometry. So, you might have wondered if you saw an aeroplane flying very high in the sky, and you also saw a bird flying. So, you might have wondered, oh, which one is flying higher? And if you saw aeroplane flying higher, then you might have wondered how high these birds are flying and how high the aeroplane is flying. Similarly, if you see any tall building, the question comes to your mind how high this tall building would be. Similarly, if you see a mountain or a very tall tree, even in fact the things which are very tall, they all inspire us. So these also inspired our old mathematicians, and they work out how to measure the heights of those tall buildings, tall mountains, tall trees. So the trigonometry was the branch of mathematics which it developed. So trigonometry studies sides and angles of triangle. And in trigonometry, it studies various trigonometric ratios and trigonometric identities. What is trigonometric ratio? It is the ratio of the sides of a triangle with respect to an acute angle of a right angle triangle. You might have heard about various trigonometric ratios like sine, cos, tan, cot, sec, cosec. But what are these trigonometric ratios? First, let us try to understand what is what are the different sides which we call with respect to an acute angle. So suppose if we have acute angle A, acute angle means its measure is less than 90 degree. So the side opposite to it or in front of it is known as opposite side, and the side which contain this angle is known as adjacent side, and the longest side of the right angle triangle we know it is known as hypotenuse. But these terminology, opposite side, adjacent side, will change if we take C as an angle. And if I want to find opposite side and adjacent side with respect to C, then the side in front of it, this will be opposite side. So with the reference to angle C, side AB will become opposite side, and side BC will become adjacent side. So I marked these sides in different color so that you can understand that for angle C, opposite side is AB and adjacent side is CB. And if we take angle A, then opposite side is BC and adjacent side is AP. Hypotenuse remains the same. So now we have understood what does opposite side or adjacent side or base means. So now we will study various trigonometric ratios. When I say ratio, that means it is the ratio of the side. So when we say sine A, it is sine of angle A. It means the ratio of opposite side to the hypotenuse. Sine A doesn't mean sine into A. It is a short form of sine of angle A. Similarly, cos A is a ratio of adjacent side to hypotenuse, and tan A is a ratio of opposite side to adjacent side. So let us, for the sake of remembering and recall opposite side as P and hypotenuse as H. So this ratio is P by H. We call adjacent side as base. So this ratio of of A, cosine of A is B by H. Similarly, tan of A is ratio P by B. So we studied these three ratios, sine A, cosine A and tan A. So, but there are also ratios which are just reciprocal of these ratios. That is cosec A is reciprocal of sine A. So it is hypotenuse divided by opposite side. Sec A or secant A, secant of angle A, whatever we want to say, is is reciprocal of cos A. It is hypotenuse by adjacent side. Cot A or cotangent of angle A is adjacent side by opposite side. I mean cotangent A is the ratio of adjacent side to the opposite side. So these angles, these ratios are reciprocal of the ratios that you studied before. Cosec A is reciprocal of sine A. Sec A reciprocal of cosec A. Cot A reciprocal of tan A. So now what can you make about the ratio of the sides? So if sine A is P by H, cosec A will be H hypotenuse divided by perpendicular side to the angle A. And what about cos A, sec A? It is reciprocal of cos A, so it will be H hypotenuse divided by adjacent side or base. And what about cot A? It will be, it was P by B here, so it is B by P here. So these are the main trigonometric ratios which we will study throughout this chapter trigonometry, and based on these ratios we'll also study some trigonometric identities. And you should always remember that these ratios are always with respect to the angle. If angle changes, these ratio, the sides in a reference will change. So instead of angle A, if we take sine C, then for angle C, the opposite side will be AB and hypotenuse is same. So sine C will be AB divided by AC, whereas sine A will be BC divided by AC. So this is an important difference we should understand, that these ratios are with reference to angle. No, these are not some permanent angles, permanent ratios for the triangle. These are the ratio for the angle. We are saying sine of angle A, and if we want to know C, sine of angle C, so we will say sine of angle C. We are not saying sine of ABC, sine of triangle ABC. It is not for the triangle. These ratios are for the angle. You know, the what is trigonometry? It studies the ratio between relation between sides and angle of a triangle. And we will always study, we'll always have a ratio of the sides of a right angle triangle. So I hope you have understood the main difference with that these ratios are with respect to the angle we are talking about. Hello dear students. So far we have studied about various trigonometric ratios like sine, cosine, then tangent, then reciprocal of these cosec, sec, and cot, cotangent. Now the question is whether these trigonometric ratios is ratio of the two sides of a right angle triangle. So if triangle is small, does the sine value is the same if the triangle is large, or the sine value increases? So for different measurement of the sides of the of the triangle, does the value of sine, cosine, and other ratios remain same, or it changes? So let us see from this triangle ABC. The point P is taken on AC and Q on taken on AB, and L is taken on AC extended to L. Similarly, M on AB extended up to M. These are all PQ, CB, LM. These are all perpendiculars on line A, Q, V, and whatever we call AM. So in these triangles, we see that angle A is common in PAQ, CAB, LAM, and these angles are 90 degree. So if I take PAQ and CAB and LAM, one angle is common, another angle is of 90 degree. So these triangles are all similar by AA theorem. So if they are similar, then their sides are in proportion. As these triangles are similar, so their corresponding sides are proportional. So in triangle APQ and ACB, AQ by QB, AQ by AB is equal to AP by AC and is equal to PQ by CB. And from these two, we get, so from these two equality, we just change denominator and numerator. So PQ comes here, AP comes here, and CB comes here. No, because that doesn't changes the equality. So we get PQ by AP is equal to CB by AC. But this is what? But this ratio is what is sine A. Sine A is opposite side by hypotenuse. Opposite side by hypotenuse. And we see that sine A, the ratio remains same. So the value of sine A remains same. Similarly, we can prove that for other ratios, the value remains the same. Hello friends, in the last video, we learned that changing the measurement of the sides of a triangle and keeping the angle same doesn't change the trigonometric values of the various ratios. Now in this session, we will learn how to find out the trigonometric ratios of some of the specific angles. So let us draw a triangle having angle A as 45 degree. So in triangle ABC, if angle A is 45 degree, we already know that B is 90 degree, then C must be 45 degree, because sum of the angles of a triangle is 180. So 90 plus 45, 135, So this angle must be 45 degree. So in this triangle, these two angles are equal. So we see it's an isoscale right angle triangle. Hence, side BC is equal to side AB. And let us assume that the measure of side AB is A. So BC is also A because these two sides are equal. Now by Pythagoras theorem, we will find out the value of AC. So by Pythagoras theorem, we know that hypotenuse is equal to square sum of the square of the sides. So it is equal to AB square plus BC square. But we have taken the value of AB as A and the BC being equal to AB is also A. So we get by this equation, so we get A square plus A square is equal to AC square. So A plus A square plus A square is 2A square. AC square is equal to 2A square. So AC is equal to root of 2 into A. So we get AC is equal to root 2A. This value we place here in this triangle. We have find out what AC is. If A, B and BC are A, then AC is root 2A. And we know that sine of an angle A is equal to BC divided by AC. So sine A is opposite side by hypotenuse. Similarly, cos A will be adjacent side or base by hypotenuse. Cos A is AB by AC. Let us now input these values. BC is A and AC is root 2A. So A is a positive value, so it becomes 1 by root 2. Similarly, what will this be? It will be also be the same because AB is the value of AB is A and value of AC is root 2A. It is given in our triangle. So this value of cos A will be same 1 by root 2. You can also make out from this triangle that BC and AB are equal. So their sine and cosine value must also be equal. So which is what is here. So similarly we can find out value of tan, cot, sec and cosec. So let us find out the value of tan A. So it will be equal to BC is A and AC is also A. So the value of tan A will be 1. And other ratios, you know that other ratios are just the reciprocal of these ratios. So from this we can easily find out the other ratios. So now we'll try to find out the ratios of the trigonometric trigonometric ratios of 30 degree and 60 degree. So if we, let us take a triangle ABC. So this is an equilateral triangle. So it has all these three sides equal, and we know the angle of equilateral triangle are of 60 degree. So all these angles are 60 degree. So now let us draw a perpendicular from A on BC. So you draw a perpendicular AD on BC. So this is a perpendicular. So this angle is 90 degree. Now let us see these two triangles ADB and ADC. Side AC is equal to side AB and side AD is common. And these two angles are by construction 90 degree. So what can you make out about these two triangles? Are they congruent? Yes, they are congruent by right hypotenuse side, because this side is common, this side and this side is equal because ABC is an equilateral triangle, and these two angles are equal, both 90 degree. So triangle AB, ADB and ADC are congruent. So we get triangle ADB congruent to triangle ADC. That means side AD is, side DB is equal to side DC. So these two sides are equal. And suppose if we take that the measure of these sides of this equilateral triangle is A, and this is A, and by congruency of these two triangles we have found out that these two sides are equal, so both will be equal to A by 2. Now these two angles, triangles are congruent, so that means that these two angles are also equal. But this complete angle is 60 degree. So this small angle will be 30 degree. So now from this same triangle we can find out the value of trigonometry ratios for 30 degree and 60 degree. Now we know side AC, which is an hypotenuse of ABD, and for angle B, this is an adjacent side. Now we need to find side AD. So we can find it out by Pythagoras theorem. So by Pythagoras, so in triangle ABD, AB is hypotenuse, AD and BD are the other two sides. So hypotenuse is equal to sum of the squares of other two sides. So AB square is equal to BD square plus AD square. Now we know AB, value of AB we know A, and value of BD we know A by 2. Now we have to find out the value of AD. Why we want to find the value of AD? Because we want to find out the values of various trigonometric ratios, and for that we should have the values of these three sides. Then we can find out trigonometric ratios for all the trigonometric ratios from sine, cos, tan, and their reciprocals. So we input these values in this equation. So we input these values. VD is equal to A by 2, AB is equal to A, and we get AD square is equal to, from the above equation, a square minus a square by 4, and this is equal to 3 by 4 a square, or AD square is this. So what will be the value of AD? We need to take square root on both these sides. So AD is equal to, we take root on both sides, so AD is equal to root of 3 by 4 a square. Root of 3 is 3, root of a square is a, root of 4 is 2. So the value of AD is equal to root 3 by 2 a. Now we have got the values of each sides of the triangle ABD. This is root 3 by 2 a. So now let us find out the various trigonometric ratios. So sin A in the triangle ABD, sorry, as, as per the triangle, I'll change it. So sin B is equal to perpendicular side AD by hypotenuse AB. Cos A is adjacent side by hypotenuse. So adjacent side is BD, hypotenuse AB, BD by AB. Tan B is equal to perpendicular side AD by adjacent side BD. So now let us input the values that we have found in this equation to get the values of these three trigonometric ratios. So we find that sin B is root 3 by 2 a divided by value of AB. So cos A will be this side BD, which is a by 2, divided by side AB, which is a. So this becomes 1 by 2. Similarly, you can find the value of tan. So the value of tan B is equal to perpendicular side, that means AD divided by BD. But AD is equal to root 3 by 2. So we input this value and we get value of tan A is equal to root 3. 2 cancel, we get tan A as root 3. So cot A will be 1 by root 3. Cot B, and sec B will be 2, and cosec B will be 2 by root 3, or 2 root 3 by 3. So now we have find out the value of the trigonometry ratios for 45, 30 and 60 degree. Now we will find the trigonometric values for 0 degree and 90 degree. So that we will solve logically. So let us now try to find out the values of trigonometric ratios for 0 degree and 90 degree. So this angle is A in triangle ABC. So what do you see if this angle approaches 90 degree? The value of BC increases. This is small, this is large, this is larger, so this should be the largest one. And almost AC becomes equal to BC, and AB becomes 0. So for sine 90 degree, BC is equal to AC, and AB is equal to 0. That means that sin 90 will be 1 and cos 90 will be, since AB value, if you see, as the value of angle is increasing, the value of side AB is decreasing, and when this angle become 90 degree, the value of AB will become 0. So cos 90 will be 0. And what about the value of tan 90? It will be perpendicular side by adjacent side. So the perpendicular side will increase, and this adjacent side will become 0. Or we take tan 90 as sin 90 by cos 90, so it is 1 by 0. So tan 90 is not defined. So now let us see the values of 0 degrees. So now let us examine if this angle becomes small and small, then what do you think the side BC will become? It was largest there, then become smaller, smaller, smaller. It is becoming, this side BC is becoming smaller. And when this angle becomes 0 degree, the side BC will become 0. So the value of sin 0 will be 0. What about cos 0? The value of AB will become equal to AC. Cos A is AB by AC. So as AC becomes, as this angle approaches 0, AC will become equal to AB. So the value of cos 0 will be, because hypotenuse and base or adjacent side will become same. So the value of cos 0 will be 1. And what about the value of tan 0? It is sin 0 by cos 0, or it is perpendicular side by base. Perpendicular side, when the angle is 0, is 0. So the tan 0 is also 0. Similarly, we can find out the other ratios, which are the reciprocals of these values. So now in this session, we have find out the values of trigonometric ratios for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So this is the summary of the trigonometric ratios for various angles, and this is the symbol. Sin A is perpendicular side by hypotenuse, cos A is base or adjacent side by hypotenuse, tan A is perpendicular side by base or adjacent side. Cosec is just reciprocal of sin A, sec A reciprocal of cos A, and cot A is reciprocal of tan A. So, good way to remember what these symbols means is Pandit Padri Prasad Hari Hari Bola. So, with this you can remember these symbols for sin A, cos, tan, and cosec, sec, and cot. The order is sin, cos, tan, and reciprocal of sin is cosec, cos, sec A, and reciprocal of tan is cot A. And the symbol is this, and how to remember it: Pandit Padri Prasad Hari Hari Bol. Now we go to the next section, that is trigonometric ratios of complementary angle. What are complementary angles? The angles whose sum is 90 degree are known as complementary angles. So if you see here, triangle ABC, which are the two angles whose sum is 90 degree? This angle is already 90 degree. So we are left with these two angles. So angle A plus angle C is 90 degrees. So these two are complementary angles. So for this angle ABC, angle A plus angle C is 90 degree. So A and C are complementary angles. Now let us write the trigonometric ratios for angle A and for angle C. For sine of A, it is perpendicular side BC by hypotenuse BC by AC. Cos A, adjacent side by hypotenuse. Adjacent side is AB, hypotenuse AC. So it is AP by AC. Tan A, opposite side by adjacent side. So it is BC by AB. Similarly, if we take C as an angle, then sine of C for C opposite side is AB. So AB by hypotenuse AC. Cos A for C adjacent side is BC. So it is BC by AC. And perpendicular side for C is AB. So for tan A is perpendicular side by adjacent side, or P by B. So P is this AB, B is BC. But A and angle C are equal to 90 degree. So in place of C we can replace C by 90 minus A. So from this equation we get C is equal to 90 minus A. So let us input C in these three equalities. So we get, so if we replace C by 90 minus A, we get this equation, this one. But if you see here, sin 90 minus A is equal to AB by AC, which is equal to cos A. So sin 90 minus A is equal to cos A. Similarly, BC by AC. So cos 90 minus A is equal to sin A. Similarly, tan 90 minus A is equal to AB by BC. So so we get tan is equal to AB by BC is equal to 90 minus A. But AB by BC is equal to cot A. That means that tan 90 minus A is equal to cot A. So we can write sin A is equal to cos 90 minus A. Cos A is equal to sin 90 minus A. Cot A is equal to tan 90 minus A. So I have written the complete set of all the trigonometric ratios for sin A and sin C. But since angle C is equal to 90 minus A, so what I have done is I have replaced angle C by 90 minus A. Just to find out what is the relation between sin 90 minus A and any of these trigonometric ratios. So now we need to match AB by AC. Where is AB by AC? So sin 90 minus A is AB by AC. Then BC by cos C or cos 90 minus A is BC by AC. So cos 90 minus A is equal to BC by AC. Tan 90 minus A, AB by AC. Where is it? Oh, sorry, AB by BC. This is here. So tan 90 minus A is equal to cot A. Then cot C, cot 90 minus A BC by AC. So cot 90 minus A is equal to tan A. Similarly, here we can match it AC by AB. So cosec 90 minus A is equal to sec A. Sec 90 minus A is equal to cosec A. So this is the relation between these complementary angles A and C, that sin 90 minus A is equal to cos A, cos 90 minus A is equal to sin A, tan 90 minus A is equal to cot A, cot 90 minus A is equal to tan A, cosec 90 minus A is equal to sec A, and sec 90 minus A is equal to cosec A. So now the question is, if because this holds true for all the values of A and B which are equal to 90 degree. So if we say angle A is equal to 0, then sin 90 minus A is sin 90, and this is sin 0, cos 0, tan 0, cot 0, cos A. So does this relationship hold? If suppose value of A is 0 or if value of A is 90. So let us see. Sin, this becomes sin 0. Sin 0, and this will be, sorry, if A is 0, then this will be sin 90. And these values will be all 0. Sin 90 is, you know, we found it previously. We can understand the relationship. If the value of A is 0 or 90 degree, then you see sin 90 minus 0. Suppose A is 0. So the value of C is 90 degree. Sin 0 is equal to cos 90. Let us see, sin 0 is 0, cos 90 is 0. Similarly, you can check for other values. So far we have learned to find out the trigonometry of various angles. We have also learned that for complementary angles, what is the relation between sine and cosec values. So from our past learning, we'll solve the exercise 8.2. The first is sin 60 cos 30 plus sin 30 into cos 60. So we just need to input the values from this table. So it is sin 60 is root 3 by 2, cos 30 is 1 by 2, so it is root 3 by 4. Similarly, sin 30 sin 6 cos 60, and then we need to add. So for all these questions, it is just inputting the values and solving. Now we come to question number 3. So we are given that tan a plus b is equal to root 3 and tan a minus b is equal to 1 by root 3. A plus b is between 0 and 90 degree and a is greater than b. So we are required to find out a and b. So this question will solve. So we need to find A and B. If tan of A plus B is equal to root 3, then A plus B must be 60 degree. If tan of A minus B is 1 by root 3, then A minus B must be 30 degree. So let us input these values. So we get that tan A plus B is equal to root 3, then that means A plus B, sum of A plus B must be 60. Tan A minus B is equal to 1 by root 3. So here we have 1 by root 3 as the value. So the value of A minus B must be 30 degree. So we now get two equations. A plus B is equal to 60 and A minus B is equal to 30. From this you can easily find out the values of A and B. So now we go to the question number 4. These are all very easy questions. You just need to check. Just need to apply a simple logic. Sin A plus B is equal to sin A plus sin B. Sin property is not additive. That is, sin A plus B is now cannot be equal to sin A plus B. So it is not additive. So this is not true. The value of sin theta increases as theta increases. So this we see here, as the value of theta increases, the value of the measure of perpendicular side increases. So this is true that sin theta increases as angle, the measurement of angle increases. What about cos theta? The base side or adjacent side decreases. Here large, small, small, and small, and small. When it approaches 90, it will be 0. So the cos theta decreases. So third one is false. Fourth one, sin theta is equal to cos theta for all values of theta. Not at all. It is only for 45 degree. That sin theta and cos theta are equal. Cot is not defined for 0. Yes, it is not defined. So we have solved exercise 8.2. Now we come to trigonometric identities. Now we go to the next section, that is trigonometric identities. So what does identities means? Identity means an equation which is true for all the values of variable. So in trigonometry, there are some equations which are true irrespective of the value of the angle. So let us take a triangle ABC in which angle B is 90 degrees. So by Pythagoras theorem, BC square plus AB square is equal to AC square. So in triangle ABC, by Pythagoras theorem, BC square plus AB square is equal to AC square. So this is our equation 1. So now let us divide equation 1 by AC square. Because AC is a positive number, it cannot be negative nor be 0. So we can divide it to both sides of the equation and the equation doesn't changes. So we get BC by AC square. BC square by AC square means BC by AC whole and bracket and outside square. Similarly, AB by AC is AB by AC whole square. AC square by AC square is 1 because AC is a positive number. But in this triangle, BC by AC is sin C and AB by AC sorry, BC by AC is cos C and AB by AC is sin C. So we replace these values by sin and cos. So we get a trigonometric identity that cos square C plus sin square C is equal to 1. So instead of C, we can write it in a more generalized way as cos square theta plus sin square theta is equal to 1. So this is our first identity. Sin square theta plus cos square theta is equal to 1. Let us now find out some other identities. So we start with the Pythagoras theorem and let us divide it by AB square on both sides of this equation. By dividing we get this equation. But let us take angle C. So BC by AB is our tan theta or tan C. AB by AB is 1 and AC by AB sorry BC by AB is cot theta base by perpendicular side and AC by AB is your cosec C. So input the cot C in BC by AB and cosec C in place of AC by AB. So we get BC by C is equal to it is cot square C. So 1 plus cot square C is equal to cosec square C. And we can write it for all generalized value of any angle. This statement holds true. So cot square theta plus 1 or 1 plus cot square theta is equal to cosec square theta. Similarly, if we divide the Pythagoras theorem by, it is divided by BC square and find out another trigonometric identity. So we again start with Pythagoras theorem and then divide this both sides of our equation by BC square. So we get BC by BC is 1, AB by BC. So if you see this triangle AB by BC is tan theta or tan C. So it is tan C. And hypotenuse by BC by base is sec C. So by replacing AB by BC by tan C and AC by BC by sec C, we get third trigonometric identity, which is 1 plus tan square C is equal to sec square C, and we can write it in generalized form